This video is on Bohr's model of the atom. We've talked about Bohr and his model of the atom, and we know that Bohr's model of the atom has rings around the nucleus that represent energy levels of the periodic table. On my periodic table, I have energy levels, and those are the rows that go across. So my first energy level is in row 1, second energy level, third, fourth, fifth, sixth, and 7th. So anything in row 1 would have 1 ring, 2 rings, and so on. So row 1 elements have 1 ring, and row 2 elements would have 2 rings because in the second energy level. So any one of these elements would have 2 rings. Remember that we have 3 different types of small atomic molecules. We can have an atom, which has the number of protons equal to its number of electrons. Isotopes, which can have more or less neutrons, depending upon which isotope it is. And I can have an ion. That's a little atom that has a charge because I've either gained or lost electrons. Electrons, on our Bohr model of the atom, are shown as dots on the energy level. And we're going to find that we put them in certain places. So electrons are represented as dots on the energy level rings. Row 1. If we look at row 1, we have hydrogen and helium. So it has 2 elements, therefore it has 2 electrons max on ring 1. Row 2 and 3, row 2 has 1, 2, 3, 4, 5, 6, 7, 8 elements. In 3, 1, 2, 3, 4, 5, 6, 7, 8 elements. So if they are 8 elements wide, that means that they're going to have 8 electrons max. So 2 and 3 has 8 elements, therefore 8 electrons max on rings 2 and 3. Row 4, in the middle, row 4 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 elements. Therefore, it can have a maximum of 18 electrons. Let's go through some examples. We're going to look at chlorine. Chlorine on our periodic table, located here, is in my 3rd energy level. 3 straight across to chlorine. That means that chlorine is going to have 3 rings. I make my nucleus. I'm going to make my nucleus an open dot because I want to add a couple of things of information to it. And I have 3 rings. 1, 2, 3. Now I'll go ahead and make all 3 of them. Now, if we look at our chlorine atom, my atomic number is 17, so that means I have 17 protons. I have no charge, so I also have 17 electrons. My neutrons are found by adding protons plus neutrons to make my mass number, so 35 minus 17 is 18 neutrons. So in my nucleus here, I have 18 neutrons, and I have 17 protons. My electrons on the outside, in my first ring, that's row 1, 2 electrons max, so I put in my 2 electrons, and I put 1 on top and 1 on the bottom. On my second ring, I continue filling, but that one can only hold 8 max, so I can add 1, 2, 3, 4, 5, 6, 7, 8. So I have a total of 10 so far, but I need to have 17. So that means on my outermost ring, I have 7 more. 1, 2, 3, 4, 5, 6, 7. On my second example, I have an ion. My number of protons stays the same at 17. And this is in fact the same for all 3 of them, because that defines that I have chlorine. My number of neutrons for my ion, well, my mass number hasn't changed. It's still 35. So my number of neutrons is the same at 18. So my nucleus and my ion and my atom look the same at 18 neutrons and 17 protons. My electrons in my ion changes. That's how I get the charge. I have a -1 charge. That means that I have one more negative electron. I have one more electron than protons, so that means I have 18 electrons. I start by filling in my first ring, 1, 2, my second ring, 1, 2, 3, 4, 5, 6, 7, 8, because they can only hold 8. So I'm at 10 total, and I have 8 more to fill. So that fills up my third outermost ring. Now for my isotope. I remember that isotopes change the number of neutrons. That means my neutrons will be different. I can see this because of the change in my mass number. I go from 35 to 38. That means that I've gained 3 more neutrons. So I now have 21 neutrons. That changes what my nucleus looks like. I have 21 neutrons and still 17 protons inside my nucleus. My electrons for my isotope, I notice no charge. That means my electrons still equal my number of protons. So my electrons look just like my atom. 2 on the first ring, 8 on my second ring, and then 7 on my outermost ring. So we can easily see the difference in our isotope, ion, and atom by looking at what changes. On my ion, my electrons change. On my isotope, my neutrons change, which I can see here and here.